Hello, it is Tuesday, and we are continuing to talk about inequalities, and you're going to find that what's on the blueprint is not exactly what we did. We didn't end up doing the back half of the blueprint because it took longer than I expected to really think about the stuff on the front half. So different classes ended up with some different ideas, and I'm going to just share the different ideas that we've got, and then we're going to continue with this thinking on Thursday to really come together and generalize and have a gelled idea about what we can do with this type of inequality. So I'm just starting with two things that should look like what you should be able to do after yesterday. These both look like the homework quiz problems that people were able to explain at the beginning of class. I'm going to do this one first. So if I wanted to solve this inequality, I'm looking for every x that would make this true. All solutions that would make this statement, 6x plus 10 is greater than 22, true. After yesterday, I know that I want to find a balance point first, because that's the place where they would be equal. And if you're not equal, you'll either be less than or greater than, which means that that is the place that the solution set will start. That will be the point that we're going to put onto our number line. So I could solve this using an algebraic method. A lot of people use number lines. I'm just going to do an algebraic method because it's easy to see. So I could take 10 off of both sides. 6x is greater than 12, which means that x is going to be greater than 2. So I think that's my solution based off of this. 2 would be my balance point, because if I plug 2 in, I would have 6x plus 10, which is 22. Both sides would be 22. So I know that my balance point is going to be at 2. But I do not know if it's going to be an open circle at 2 or a closed circle at 2. If it's open, then 2 is not a solution. It would not make this true. And if it's closed, 2 would make this true. Well, I know that 22 can't be greater than 22. So that means 2, even though it's my balance point, is not a solution. So I'm going to have an open circle here. Now I just have to be sure. We think it's x is greater than 2. I need to confirm that before I graph it. So I'm going to pick something that's in what I think is my solution set. I'm going to try 3. If I plug 3 in, I would have, so we're going to say try 3. If I plug 3 in, I would have 6 times 3, which would be 18, plus 10 would be 28. 28 is greater than 22, so the inequality holds. That makes this a true statement. So yes, in fact, we can go to the right. X is greater than 2. This one's very similar. The math is just a little bit more tricky in that you've got some fraction or decimal values. So you could add 10 to both sides to balance that out. 6x is going to be greater than or equal to 22. If you divide by 6 to get x, x is going to be greater than or equal to 22 sixths, which reduces to 3 and 2/3. So if I had 3 and 2/3 here as my solution, well, that's between 3 and 4. So we could use 3 and 4 as our test cases. We think it's going to be greater. So let's put it this way, and then let's check 4. If I try 4, I would have 6 times 4, which is 24, minus 10, which is 14. 14 is greater than or equal to 12, so 4 is correct. That means that 4 is a solution that's going to work here. So for both of these, it seems like you can kind of just work straight through it, and your inequality is going to hold at your balance point. But what happens if we throw something new in? If we throw in negative multipliers. So if we had negative 6x plus 10 is greater than or equal to 22. Very similar to that first problem. Only thing that's changed is I now have a negative 6, and then I also just changed it from greater than to greater than or equal to. So this time, since I see a negative 6x and I'm like, well, if I added, things might get messy, I'm going to use a number trick. It's another possibility. So if I had x times negative 6 plus 10, remember multiplication comes before addition, equals 22 minus 10, divide by negative 6, x needs to equal negative 2. That would be my balance point. So then down here, I know that negative 2 is my balance point. It can be equal. 22 equals 22. So it's going to be filled in. Now I just need to decide, is x going to be less than or greater than negative 2? If I were to carry down the inequality symbol, like some people were doing, I would assume that I need to do x is greater than or equal to -2. Let's test, and that would be going this way. Let's test something to be sure. So since I'm at -2, why not do -1 and -3? Those are right on either side. Let's test -1. If I try -1, -6 times -1 would be +6. +6 plus 10 would be 16. Is 16 greater than or equal to 22? No. So this is not correct. So you cannot go up to -1. That actually doesn't work. Let's check the other way to be sure. Now let's try -3. -6 times -3 would be +18, plus 10 would be 28. 28, is that greater than or equal to 22? Yes. So actually, it's not x is greater than or equal to -2, it's that x is less than or equal to -2. We had people starting to notice that the inequality was reversing or flipping for some reason when you had this negative thing that was being multiplied. We looked at one other one to see if that continued to hold. That was a lot like the second one. -6 minus 10 is greater than 12. And if you use a number trick here, x times -6 minus 10 is 12. Plus 10, 22 divided by -6. You're going to have -22/6, which was, we already figured out, -3 2/3. So we think that it would be greater than if we were just following down from the problem. But let's check. -3 2/3 would be between -3 and -4, as you're going more negative. So I'm going to put, it's open because that cannot be a solution. There's no equal sign there. So let's check -3 first, since we thought it needed to be greater than. If I did -3 times -6, I would have +18. 18 minus 10 would be 8. 8 is not greater than 12. So -6 does not work. Now if I tried -4, and I did -6 times -4, that would be 24. 24 minus 10 would be 14. Is 14 greater than 12? Yes. So we would go in the direction of -4, which tells us that x actually has to be less than -3 2/3. So something is happening that is causing the inequality symbol to reverse or to flip. And that's why it's really important that you always are testing values, because you might end up with something that is going to kind of trick what you think is going to happen. You thought, I just go through the problem and the inequality is going to hold, but something's going on with that negative multiplier that is causing it to reverse. We're going to continue looking at that on Thursday, but as you're working on the homework before then, think about making sure that you are testing solutions. And I say that, I even bold it. You don't all pay attention even when it's bolded, but I'm trying. It says, make sure to test possible solutions on both sides of your balance point. Good rule of thumb would be to try the number that is directly on the left and on the right, the next whole numbers on either side, because those would be easy, or the next integers if you're negative. Okay, so that's all. Tomorrow, this is not due, because tomorrow we'll be doing some escape room stuff to talk about inequalities, as well as some Dreambox, and we'll get to see some awards for you guys, which should be cool. But then we will return to this on Thursday. That means you have 2 nights that you can ask me questions if you need to, so do it.